correctly this time. We have.
Nice.
I think I've always clicked the wrong button. It's either never not recorded or it's not gone live.
Yep.
Anyways, for people who are joining, we're going to start in a couple of minutes. Yeah, and then who knew that YouTube Live was relatively complicated?
Yeah.
We had to use a whole other product to actually get it to work. So
I think this is you win as my first official time on a live stream. Is now.
Nice. Yeah.
Yeah.
I like that.
don't think I've been on a live stream before. I've seen them, but
well, next week you're gonna have a live coding session where people are gonna watch you code.
Great.
And then you're gonna have 100 people being like, "Oh, I think you have a bug on line 62."
Yeah. I have to censor the constant swearing under my breath when I do the same thing I've done 100 times.
Yeah. That's what I need my my editor to do, is just be like, you said this word again. Like I'm gonna prevent you from ever.
Yeah. Yeah, you're doing that thing you do.
Yeah, so Seattle, the weather, we have 20 seconds or so, but the weather is better.
Yep.
The weather is amazing here. I'm just honestly so excited for the weekend.
It is. We're finally in it's pretty consistent now. There's still going to be, in May, you still get random, it'll be cloudy and rainy, but you're kind of through the worst of the dark, and it's mostly you can kind of count on the weather a little bit more to do stuff outside and things like that. So yeah, it's nice, man. Bright sun. You miss bright sun after too long.
I don't know what that's like living in San Francisco. It's pretty good, actually.
Right. So. Yeah, you guys pretty much always have the sun. Yeah.
You should travel here more often as well.
Yeah. Yep.
All right, let's do this thing. I have Hayden here. We're doing the live stream because Hayden is in Seattle. I'm in San Francisco. This is Interrupt Live, and this time we're talking through Hayden's interrupt post that he published actually relatively recently. Usually we're pulling posts from the graves from deep in the past, but this is actually one of our most recent posts. And Hayden had kind of generated a checklist that he himself had personally kind of written down. Did you actually write it down? Is this actually a checklist you had before? Or is this one you made for this post?
Yeah, for the post. I mean, kind of in my head. It was like an in my head checklist that I'd sort of developed over time. And kind of the impetus being, I'm relatively new to firmware full time, call it 3 or 4 years now at this point. And the first time I got a bug where, it's not on your computer, it's on something else, and everything just stops, was insanely intimidating, right? Where you're like, oh, I don't even know where to start. It just doesn't work. It was working and now it doesn't work. So that was kind of the motivation, was that can just be super intimidating and kind of hard to stomach the first time you encounter that, coming from if you've been coding desktop applications or something where you get this nice stack trace.
Oh man, if only we got nice stack traces.
Yep.
If only. So that's what we're going to be talking about. We're going to be talking about the inspiration behind the post, some other things and other nuggets that I found in the post that weren't necessarily the main conversation topics there, but I want to dig into more, like Doom on the coffee maker.
Yeah, of course.
We'll get through whatever. We'll ramble about whatever we get into for the next 20 minutes or so. But first, I'll let Hayden introduce yourself. You have, I guess, a few minutes. What I'd like to ask here is how did you get into firmware? What's your favorite part? And what are you up to these days?
For sure. Yeah, I'm Hayden. Nice to meet everyone. So I started coding in general. I was an electrical engineer. I went to Georgia Tech. And MATLAB was my first language, for anyone who knows that, which is quite an introduction. Right out of college, I went to work at Texas Instruments. I was a silicon test engineer, so kind of firmware adjacent, coding very, very large production tester machines that would test ICs as they came off the line. So you'd be controlling voltage sources, patterns, getting the device into test mode. My favorite fun fact about that is, so this is kind of more coding. I'm getting into more coding. One of the testers was you would code it in Excel macros in Visual Basic Advanced. They thought engineers love Excel.
State of the art.
state of the art. So you would literally open Excel that had your little thing. You'd open the macro editor, and they had these hideous like DLL plugins they had that would control a $1 million tester with Microsoft Excel. And it was exactly as fun as that sounds. So yeah, after TI, I moved to Seattle. I worked for a company called Impinj for a while that does RFID systems. Was doing more like whole system sort of scripting and orchestrating RFID readers. And then I moved to my current job for almost 3 years at Terra Cafe. We make that guy. It's a home espresso machine. And that was my first like deep dive lead firmware engineer. And I just really liked it. It's kind of the perfect marriage of hardware and software, still being very low level, close to making stuff move and seeing stuff light up. And yeah, that's kind of how I arrived at firmware engineering.
Yeah. I guess how big is the team at this company? How many other engineers do you have alongside you, whether that's hardware or the software or firmware?
Yeah. Yep. So not very many. I'm the only firmware engineer. We have a cloud engineer and a quality engineer. And that's about it. So
you're the hardware team too, or like you're the electrical engineer as well. So you're doing
correct. Yeah. Yep. And a lot of that, a lot of that we can contract out to engineering firms and things like that. If like a whole board needs to be designed or something. But yeah, I am the kind of resident consultant for all things electrical and firmware.
What's your favorite part?
Oh.
I guess in the last year, what was your favorite project?
Yeah. Oh boy. All right. Getting some auto focusing. Yeah. Too much swaying. Favorite part was, I think the machine. It's very, very fun the speed of this is a feature we want and seeing it come to life on the screen or just in what the control board is doing with pumps and motors is very, very cool. Just being able to very quickly change how a drink is brewed or milk is frothed or something like that is very satisfying. It fulfills that need for a lot of times software can get really abstract and you're not quite sure what your output is or is going to be. And so it's cool to have a very concrete, this is the output of what my code does. And I'm drinking it.
And it tastes great, or it tastes terrible.
Yeah, or it doesn't taste good. Yes, exactly. I messed up. Yeah.
Got it. Very cool. So one thing, it was at the very end of your post, one thing that I think I want to start with, because I think it's your post has great content, people can read it. What I really am very curious about is Doom on the coffee machine.
Yes.
And so what was the inspiration behind that?
Yeah, so as I'm sure many people are familiar with, there's a huge community around getting Doom to run on honestly far harder things than the coffee machine. Yeah. But yeah, one of our creative director was like, "Hey, do you think you get Doom to run?"
So it wasn't even your idea.
No.
Here I am thinking it's Hayden's idea. And
it was funny though, because it was one of those weird simultaneous, because he recommended it and I had been kind of looking at whatever, on Reddit and stuff like that. You see posts and I'm like, yeah, that could probably run on our machine, but it was just sort of, didn't. And so I was like, oh yeah. And yeah, looking it up, I found projects where it's people were running it on an ST discovery board, which is a very similar chip. We use an ST chip on there's two boards, but the board that runs the user interface and the touch screen. And yeah, it was one of those things where you're like, well, I'll probably hit something that means it's not going to work. And then I just never hit that. I just kept kind of going. And it was cool. It was, what I think I loved about that project is it used every part of that board and firmware. It exercised almost every path, which I wasn't anticipating.
Got it. Did it actually use most of the resources too? A lot of the code space, a lot of the RAM, it was actually pretty hard to.
Yeah. It was kind of awesome. It was okay, the shareware version of Doom, for those not familiar, it's much smaller. It's only the first level. That takes up most of the quad SPI flash, great. The the entirety of the external RAM IC is used to give just more RAM. It's like most of the internal RAM and all of the external RAM is used running the game. And the other persistent storage, the normal SPI flash we have, is used to do save games, which is very fun and entirely unnecessary, but was just
it was just like
yeah, right. Like I was like, well, okay, I'm gonna implement it. Like if I can, it's very funny. It takes like probably 25 seconds to save the game because it's really slow. It's not a fast interface, but it works.
Very cool. So I was hoping there was a Konami code to unlock Doom on the coffee maker, but it's not fitting with the normal firmware. So
no, it's the kind of thing where it's like,
There's
yeah,
no way.
you can either brew coffee or run Doom. You cannot.
Exactly.
Yeah.
And you were saying you ran into a bug on Doom, and that was the hardest bug that you've run into maybe ever. And like, how long did it take you to solve that bug? Or like, I don't think you actually you quoted a time on how long you spent on that.
No, yeah, it was definitely in the like week range.
Okay, got it.
It wasn't like horrible, but it was just such a strange. So for context, for people who haven't read the post, basically there was a bug where I hadn't gotten anything working right, because I'm just getting the engine, like trying to get the engine and subbing a ton of stuff in the engine for my own stuff, right? Using my own memory allocation stuff. And so I'm assuming that it's somewhere in there. And I just kept hitting hard faults. And the hard fault was an invalid memory address. And I was sure that it was something related to, because what it was doing was it was loading the WAD, basically the game files, into RAM. It's their own specific kind of compression scheme. And it was hitting a hard fault. And it was odd because it wasn't like the same spot every time. And sometimes if you would get to the Doom splash screen, so at first you're like, oh my God, I'm like so close to it working. I'm seeing stuff on the screen.
It's kind of random or crazy that it was random whether you'd actually get to the screen or not. I feel like some of these systems don't have any randomness at all in them.
No, right.
Do the same exact thing every single time, but
yeah,
that's corruption for you.
Yes. Well, and the funny thing about the randomness is because it was electrical randomness. It was a floating pin, so what ended up happening was I misconfigured there's a whole other rant about hardware house, or vendor house, but I basically just left a single pin on the RAM IC unconfigured. And what that pin does is lower byte masking. So what I did was when it would just float a little bit too high, it would mask the most significant byte and make it all Fs when you fetch something from that SDRAM IC, which is why sometimes you get to the splash screen. Because what was happening is, depending on which asset got corrupted or not loaded, the Doom engine is pretty resilient. It's like, okay, we're fine. We don't need that texture, or we don't need that whatever, and it'll just keep going. Yeah, it'll keep going. So you get to the splash screen and like certain things would be missing and it'd be different. And I'm like, what in the world is going on? Do I have a corrupt? I was like, oh, do I have some weird? Is it the file that I'm loading? Is it the version I have? Is there a bug in the engine? No, it was good old electricity. And then fixing that, it was the bug where it just unlocks everything. It was like, oh my God, it just works.
Everything works, yeah.
Like I'm done. Like it was literally the last.
This thing.
yeah. It was like because I had inspected every other part of the code, right, and found other bugs too that were unrelated. Where it was like, oh, okay, yeah, I'm doing this wrong. This must be it. So yeah, by the time I finally got that, it was like, oh, I'm done. It just works. So amazing. Yeah.
Love it, and I hope we see more Doom on other machines with massive touch screens and stuff like that.
Yeah.
So, one thing I did want to talk about is you now work alone, basically as a solo firmware engineer and electrical engineer. You used to work with a team of firmware engineers. Like, what are the pros and cons? How do you handle it?
Yeah. I'd say pros are unilateral decisions. You can do whatever decisions. Yeah, you can do whatever you want. If you want to change the entire code base, you are more than welcome to. And so speed. speed. That's definitely a pro. You can implement stuff really fast. The cons are you don't have anyone looking over your shoulder. You don't really have code review. I mean, you can have a code review with yourself, but there's not code reviews, so you have to be, especially given, we are in production now. There's, I think, a different mindset with making changes. It's not just about like getting the feature in as fast as you can. It's like, oh man, okay, what other pieces of the system did this touch potentially? And a lot of planning regarding like regression testing and catching potential slip ups, because it's not a matter of if there's going to be bugs, it's when there's going to, it's when. No one's perfect. So
have you changed? Are there specific behaviors that you have changed? Like, do you make a design doc? Are you just coding now? Do you write unit tests first? Like, are there any things that you realize that just work better when you're a single engineer?
Yeah, I think that's a good question, actually. Yeah, what has really changed? I guess, yeah, a little bit more testing when there's something that can be unit tested, if that makes sense. And yeah, we do generally, as part of a process, the sort of first step is writing some kind of doc that describes the feature, which just helps with everything. I mean, implementing it too, just knowing what the stakeholders at the company want out of it. So definitely a little bit more process on that side. And then I think just, I don't know if this is a solo change as much as a we're in production phase, but just way more careful consideration about changes too.
Got it. I guess another question I had is a really interesting point that Mark made when I had an interrupt live with him a few weeks back. And he worked for Lyft, scooters and bikes, a lot of engineers. And one thing he had pointed out during his time there is they shipped firmware updates almost as often as possible, like every few weeks, because then they would basically, it's also in your blog post, like find the diff between the two code change sets, basically. And if they shipped more often, they'd have less changes between the two, and they could figure out more quickly like what likely caused an issue. I guess is aspirational versus realistic. Like, are you shipping firmware update often enough to be able to do that? Do you like to ship it more often, or just test it rigorously?
Yeah, no, good question. I think a lot of that is infrastructure dependent on your images. True. So like I think ideally, yes, if the caveats I'll add is if it's really easy to roll back and it's very fast to deploy to lots of devices, absolutely. Incremental changes are way better than big changes. What we run into a little bit is firmware, just because of the service we're using, firmware doesn't deploy super quickly to all devices. It's still on order of like a week, but there's also sort of it's optional to have the device online. You don't need to have the device online. You can use the coffee machine entirely offline for,
because these are consumers. They don't have to connect it. They don't have to update it also.
Exactly. So yeah, so there's a bit of that as well. There is a cost associated basically with deploying. Like, it just takes a bit. So that being said, we generally do updates 4 times a year. So once every couple months. So not entirely, not super slow. And we don't, we'll do a variety of new features, but we're not doing massive, huge sweeping changes each time. But yeah, I agree. If it's easy to do, I think small incremental changes are great, because then you can do like phased deployment type strategies too, where you try 20% of the population with a small incremental change, and then if it doesn't work, you can roll back relatively easily.
Got it. Is there this is a curiosity question. Is there a particular firmware update that you were excited about as a firmware engineer for this coffee maker?
Yeah, we did. This was almost more just an engineering thing we did, but we did a lot of optimization around espresso temperature. That was pretty cool. That was, can't remember. I think that was sometime last year that we did that update. But I was excited for that update because there was just a lot of cool. It made the drinks hotter, which was kind of the goal. So that was the culmination of. It's funny, not a ton of coding, more a lot of testing and experimentation for what can we do to kind of the temperature control algorithm to boost it a little bit higher.
Got it. I think my camera just got messed up. I'm gonna do this real quick. Yeah, now we're in this view.
There we go.
One last thing you wanted to talk about was Zigg. I was excited to talk about Zigg. I think I always get my ear talked off about Rust. You're a proponent of Zigg. Tell me more.
Yes, absolutely. So the Zigg programming language is something I kind of stumbled on, I'd say a year or two ago now. And I love it. I think the best way I can describe it is it is the modern C in every sense of that word. It's C with a lot more niceties. Big features I'll highlight. Runtime safety checks by default. So it is not, whereas Rust tries to do a lot of safety checks via the borrow checker and like lifetime annotations via the compiler. Zigg does a lot of those, not quite the same, but does a lot at runtime instead. So indexing off an array, runtime checked by default, unwrapping an optional type. They have optionals in the language. So if you say, hey, I think there's something here, and it turns out there's not, also safety check. There's a lot more that I'm missing. But what I like is it's opt-in, or it's on by default, and you can opt out. So there is a release fast mode that if you are uber concerned about like minute performance, you can turn off those checks and kind of go back to what C is, right? Which is undefined behavior if you index off the end of an array. Other killer features are comp time. So compile time is what it's called, which is basically you are just coding in the same language and syntax, but it happens at compile time, which is awesome. So imagine like C++ templates if the language weren't hideous and unusable. So it's kind of how it's cool. It's how they implement generics. So for instance, you can have a function that returns a type at compile time. So not at runtime, you can't do dynamic types at runtime. And then the other one I really like, and this is probably the big one, is no hidden control flow and no hidden memory allocations. So
what do you mean by that?
Yes, so there is no constructors, destructors, like there's no, what you see is generally speaking what is happening, which I think is super important for like really low level bare metal.
Yep.
The allocations thing is awesome, where in the Zigg standard library, if anything requires memory allocation, you must pass it an allocator. So what's cool is that then by default, the entire Zigg standard library is available to you on bare metal, now excluding file system stuff, right? And what's really cool about that is a lot of times when I'm coding, I don't actually need dynamic memory allocation. I just need like an 100 character buffer to do some string manipulation.
Yep.
And what's cool is in Zigg, there's an allocator type that is a fixed buffer allocator. And so now you can make a fixed buffer allocator of 100 bytes, and you can now use any function in the standard library that requires allocation. And it'll panic if it tries to allocate, past its 100, past the size you gave it. So yeah, it's just really cool. I've had a lot of, there's a lot of anxiety associated with using like the C++ standard library.
Yeah, you don't know what's gonna happen under the hood, basically.
Yeah, exactly. There's all sorts of stuff that calls, and you're like, okay, well, wait, where have I set up my malloc or my sbreak function correctly? Is that all configured? And so a lot of that goes away. So that's maybe a bit of a rambling pitch for Zigg, but I've really enjoyed it on embedded. I've done a couple small projects in it now, and it is just an incredibly productive language, like really productive.
Yeah, and you have. Go ahead, please.
Sorry, I was just gonna say, I missed a big one. The C interoperability is amazing on that language. The Zigg compiler is a C compiler, and you can mix C code and Zigg code, I would say, like trivially easy.
That's awesome. So people can basically slowly migrate their code base to Zigg if they want to, or just pieces of it.
Yes, exactly. You could compile your entire C project with no Zigg. Just the build system, also written in Zigg. You use normal Zigg syntax for it. Yes, you could transition to the build system, keep all your code in C, and like sample, have a single file in Zigg to try some stuff out. Yeah.
That's pretty cool. I think we're using the Zigg compiler and a lot of our CI to just do unit testing and like quick builds as well, because it's honestly way easier to get working than GCC sometimes. So
no, right, because they made, I think the huge thing is they made their compiler like built for cross-platform. Like that was kind of their huge goal, is be able to compile for 100 different systems sort of trivially easy. Yeah.
Got it. I think it's about all the time we have, Hayden. Thanks for chatting with us. I was excited to learn more about the Rust inspiration. I'm glad it was actually driven by somebody internally at the coffee company instead of just you.
Yeah.
Because I don't know, that brings me joy. Thanks for sharing about Zigg and sharing the checklist in general. I'll continue to point people to it, because now we have Mark Schulte from last week. We have his like hardware schematic checklist, things how not to mess up your hardware. Now we have things how to not mess up your firmware or when you get into a bad place. Any final words of wisdom for the crowd?
Oh boy, on the spot.
No pressure, but
yeah. Know how your RAM's configured. know how your memory is set up in every sense of that word.
Oh my God,
hardware, software, where your stack is. That's the number one thing that.
Look at the linker script and know it by heart.
Yeah. Yes.
And if you don't have it from your IDE, make sure you can actually get it.
Yes.
Oh, we run into that so often. Okay, cool. Thank you, Hayden, and have a great day.
Awesome. You too.
Yeah. Thanks for listening, everybody.